Ladies and gentlemen, good day. My name is Rostislav. I represent myself and another author, Alexey Semyonovich Sirotkin, who is the head of School of Material Science Engineering in Kazan State Power Engineering University in Russia. We would like to present you a report or a paper for modern materialistic understanding of the energy notion and the method of its systemic evaluation in chemicals. I would like to say that there is the presence of two major global problems or issues in the development of scientific knowledge nowadays. First, this is the issue of scientific knowledge fragmentation and the need for the development of a single universal view of the structure of the universe. The second issue is the growing contradiction between the accumulated fragmented empirical information, which is scattered among about 17,000 different scientific disciplines, and the significant part of the traditional but outdated scientific paradigms. Next slide. For engineering universities like ours, the concept of energy is of particular importance, but the meaning of its traditional definitions needs to be clarified and evolutionarily developed. However, the meaning of the concept of energy is traditionally presented not as an objective material reality, but only as a hypothetical physical quantity that can perform work, etc. That is, as a property, but not quite clear property. Next slide. His lectures on physics delivered between 1961 and 1963 at the California University of Technology, the American physicist Feynman noted that there is a certain quantity called energy which does not change under any transformations occurring in nature. This statement is very, very abstract. It is essentially a mathematical principle. It is important to understand that the physics of today does not know what energy is. In 2001, Lachkov and his colleagues in Ukraine, when asked what the concept of energy is, replied that by and large, the concept of energy, the idea of energy, is artificial and created specifically to be the result of our thoughts about the world around us. According to the authors of this paper, energy is an objective material reality that is widely used by humanity. This is why the aim of this work is to consider and clarify the meaning of the concept of energy, the framework of contemporary views on structure and properties of matter, and to consider the option of a systemic assessment of chemical energy through a system of chemical bonds and compounds in the form of a chemical triangle. In 1905, Albert Einstein showed the following relationship between the mass of physical object or substance and its energy, represented by equation 1, where c is the speed of light in a vacuum. In this case, equation 1 is associated not just with the energy of any material body, but with the bond energy of elements in an atomic nucleus. It demonstrates the relationship between the transformations of matter according to the phenomenon of mass energy conservation and the transition from one type of matter to another, and vice versa. In general, the law of conservation of mass and energy is demonstrated by figure 1. According to this figure, general, the specific energy of the intrastructural interaction of the elements that make up various substances and matter attributed to the unit of their mass decreases as the latter increases. That is, energy is a continuous field type of matter or an energy continuum. It exists in the form of open or closed closed within discrete forms of matter fields. Types of energy differ in terms of their carriers, that is composition, gravitons, quarks, electrons, etc. Structure, localization, delocalization of open or closed fields in space, and further properties. Wave characteristics, the magnitude of local and non-local effects on other material objects, and penetration into substances and material bodies. The ability to interact with other material objects, including the binding of elements of various substances and material bodies in general. The ability to determine the forms of motion, physical, chemical, biological, mechanical, etc. The interaction and transformation of material objects, fields, substances, material bodies, and so on. Or the possibility of transition from some forms of motion and varieties of matter to others. And finally, the ability to perform various types of work, chemical, electrical, thermal, and so on. The most important distinguishing feature of the continuous forms of existence of the material energy continuum in the form of fields is possessing by the latter the wave characteristics, which vary in a fairly wide range. Figure 2 represents the scale of electromagnetic waves, while understanding that the wave characteristics of gravitational, nuclear, chemical, and other fields would differ from the above electromagnetic ones. Next slide. Since chemical energy is the main source of heat and electricity for humankind, the authors propose a new scientific foundation for the systematization and quantitative assessment of the energy characteristics of chemical compounds of elements. It is based on a comprehensive assessment of the constitution and composition of chemical compounds and their chemical bond type, based on a single model of chemical bond and the system of chemical bonds of compounds in the form of a chemical triangle, which is shown. Chemical triangle is a system of chemical bonds, compounds that are formed by these bonds, which combines homo and heteronuclear binary chemical compounds in the form of non-molecular, metallic, ionic, as well as molecular, mono, oligo, and macromolecular compounds, along with polymer bodies. Chemical energy is an objective reality in the form of an energy continuum, a closed electric field between the total negative charge of shared electrons and the positive charge of chemical elements in the form of nuclei, or more precisely, more correctly, atomic skeletons. Substance arising in the process of their exchange electrostatic interaction ensures the occurrence in it of a chemical bond and an equilibrium, closed, stable chemical system, a chemical substance. As a result, on the basis of chemical triangle, the foundations were laid for the first time to create a database of systemic digitalization and evaluation of energy stored in various chemicals, such as gas, coal, oil, heat, and the most effective ways to extract these from these. The extreme natural character of the impact of composition and chemical bond type on energy characteristics of substances was shown, depending on the gradual change in the ratio of covalent and metallic bond components, homonuclear, and additionally ionic bond component in heteronuclear compounds of elements. That is the conclusions of the work. This work, it was shown that energy as well as matter objectively exist in the form of various material varieties. Energy is a continuous field type of matter, the energy continuum. It exists in the form of open or closed within discrete forms of matter fields. They differ in structure, including the ability to perform different types of work, to determine the forms of interaction and movement of matter in various material systems, substances, material bodies, megamaterial systems. And second conclusion, a new scientific foundation is proposed for the quantitative assessment, systematization, and digitalization of the energy characteristics of the entire array of chemical compounds of elements, based on the system of chemical bonds and compounds in the form of a chemical triangle. This is the end of our report. Thank you for your attention.